Lesson 6, the big picture for quadratic equations. Okay, so let's start talking about what we're going to be doing here. So, um, what we're going to do on this first part is we're going to graph these things. Y is equal to 3x minus 6 on these grids below. And we're going to see what that has to do with solving when y is equal to 0. You can see that there's a y there and there's a 0 there. So we're just saying y is equal to 0. So when you graph these things, a general rule of thumb, if it's a line, like a straight line, like, something like that, you need to graph at least 3 points. If it's a curved line, which was really what we're going to be doing this unit with quadratics, is you need at least 5 points to kind of show that that's what that curve would look like. So something like that, and that. So you can be accurate with your curve. All right, so we're at the bat. Let's solve this equation when we got 3x minus 6 is equal to 0. So if you rearrange this, we would have 3x is equal to 6, right? If you just like add 6 to both sides. Then divide both sides by 3, we've got x is equal to 2. So hold on to that for a minute, that idea, x is equal to 2, right? What I'd like you to do now, go to your calculator, and if you have a TI Inspire like this one, it's going to look like this. If you've got a TI 83, it'll look a little bit different. Hopefully you can remember how to use your TI 83. On the TI Inspire, when you're going to go to the home screen and then go graph. Actually, I've got something in there already, so I'm going to go on the home screen. I'm going to go new document and then add graphs. So I kind of start over again. If you had a TI-83, you're going to have some buttons kind of up in this area. One's going to say like, graph or, whatever. And instead of F1, yours will say like Y1 instead. It means the same thing, like F and Y, or F of X and Y really mean the same thing as far as we're concerned. For now, anyway. Okay, so let's put this into our calculator. So it says graph Y is equal to 3x minus 6. That's the same as f of x is equal to 3x minus 6. We're going to go 3x minus 6. Okay, so I get a straight line like that, right? Now, if I want to figure out, how to actually graph that, because I can look on here and be like, okay, I could get that close, but how would I know what the points are? If you go to menu and then down to table, and then probably just a split screen there, we get it. It makes us a table. So you can see that in this column we've got our x values, right? So like -1, 0, 1, 2, goes down to 3. These are all of our y values, or our f of x values. So we can just really just plot these now. But here for this first one, I'm going to make a little table so we can keep this straight. So when x is -1, y is -9. Okay, when x is... Oh, that was wrong. When x is 0... Actually, let's do... Yeah, we'll do that one. When x is 0, y is -6. When x is 2... y is 0. And when x is 3, y is 3. Okay, so now we can plot these things. So let's go down here and just kind of, we'll generally plot these 4 points maybe. So x is -1. So what I'm going to do is go over 1 on my chart here. And then I'm going to go down 9. So our first point looks like it's right there. When x is 0, y is -6, so right there. I want you to kind of know this. Maybe you remember from grade 6, or grade 6, grade 10. -6, this number back here, that told us our y-intercept, where this thing was going to cross. Anyway, okay, now when x is 2, y is 0, so right there. When x is 3, y is 3, so right there. So you can see we've got a straight line that goes up like this. Should have been straighter than that. But you can kind of see, going back to our original solving this equation, we got 2 for an answer, right? where does 2 come up in our graph? Well, 2 comes up right here, right where it crosses the x-intercept, right where y is 0, right? We put a 0 instead of a y there, right? So we had, this was our graph, but instead of having a y, we put a 0. So when we put that 0 there, that's what x would be. So you could solve for that. So that's kind of what we're going to be doing, is solving for x a lot of the time. And that is going to tell us where it crosses the x-intercept. As we're looking at that, though, I want to make sure you guys know where these like x and y numbers come from. So I just want to throw in a couple more here. So let's say, so I'm going to start off with y is equal to 3x minus 6. And let's say that I just put 2 in place of x, right? So I'm going to throw in a 2 right in there. So let's say, okay, y is equal to 3 times 2 minus 6. Well, 3 times 2 is 6, minus 6 is 0. So y is equal to 0. That's where this 0 came from. Let's say I put a 3 in there. So again, I'm going to go y is equal to 3 times 3 minus 6. What's the y that I get out? Well, that's 9 minus 6. That's 3. That's where this came from. So when I put in a 3, I get out a 3. Y is equal to 3. So hopefully that kind of makes sense, or you kind of remember that from grade 10. Okay, so just for the sake of time for this video, I'm going to let you guys go ahead and you can do these two for practice to kind of see what that's like. Or you can skip it if you think you're kind of ready. But I'm going to move on. Okay, so what is the relationship between the solution of f of x is equal to 0 and the graph of y is equal to f of x? What I mean by that is, so f of x is equal to 0. That would be something like 2x minus 6 is equal to 0. We call this f of x. That's the function. Okay, so that's f of x. And the graph of y is equal to f of x, well, that's going to be y is equal to then like 2x minus 6. And they're saying, what do these things have to do with each other? Well, it's kind of like what we talked about up top there. If you were graphing this thing, this is where our graph crosses the x-intercept. So if you solve for x in that case, you're going to figure out where it crosses the x-axis. Okay. All right, moving on. So now what we're going to be dealing with is a different kind of equation. We're dealing with y is equal to x squared plus x minus 6. So before we get into this, I just want to make a little, I just want to kind of show you something. Let's go to here. I've got this little gizmo thing. And I've got these dials over here. And you can see that it says y is equal to, and so far, since they're all just sitting at 0, it's 0x squared plus 0x plus 0. So like nothing, no equation, right? Just a straight line going across the bottom. Well, the ones that we have been doing have been something more like this, right? Where it had some kind of number. Let's say it was like, I can change it exactly here. Okay, so like 1x, and then for the last value, I don't know, it would be like 3 or something, right? So you can see that that's what we were dealing with. It was like a line, like a straight line. Now what we're dealing with, let's go back to 0. And now we have an x squared term. So I'm going to have something in place of here. So let's even just put like a 1 in there for now. You can see that now we're dealing with curves like this. And if I made, I don't know, b equal to negative 2, it changes it and moves it around, right? If I make c equal to negative 4, then it moves it down there. So this is what we're dealing with, is these equations, though, where it's going to be like an x squared minus 2x minus 4. And what does that look like? And what does it mean? So let's go back now to this question. We've got y is equal to x squared, so that'd be like 1x squared plus 1x, and then plus negative 6 or minus 6. If you graphed it in your calculator, so it might be the easiest just to go home and then maybe new document. I don't need to save that last one. Go add graphs. Okay, now I've got x squared plus x minus 6. Right, so that's what my graph looks like, right? So if you go into menu and then table again, and we can put a table up here, I can plot a few of these points. All right, so if you look at my table here, and I just put down 5 points there. I put down the point where it crosses the y-intercept, and ooh, I made a mistake. That should be down one more. Crossed at -6. It looks like. Okay. Okay, and I've just plotted these points. So you can see that I had, if I go up a little bit, when x was -3, so -3 over, y was equal to 0. So that's that point, right? And then I just plotted when x was equal to -2, y was equal to -4. So that's where that one came from. That's that right there. And then at 0, it was -6. So that's where that came from. And then it's 0 again here at when x is 2 and y is equal to 0. So now our graph would look something like this, right? With a x-intercept, if you put that in brackets there, the x-intercept would be at 2, 0. And this one would be at -3, 0. Oh, remember that the first letter is the x value, the second is the y value. Okay, so those are our x-intercepts anyway, right? We got that from our table. Now, what it says to do is factor x squared plus x minus 6. So let's do that down here. We got x squared plus x plus 6. Was it plus 6? Minus 6. Okay, and it also says solve x squared plus x minus 6 is equal to 0. I'll show you what I mean by that. So if we factored this, so just like we were doing in the last one, told you factoring was going to come back in. So we're going to have x and an x. My two numbers need to multiply to 6, add to 1. So what about 2 and 3? And then this would be a positive and this would be a negative. Okay, so we factored it. Now, the next part says solve for that. So this really is this, right? We haven't really, all we've done is rewrite it in a different form. Let's make that equal to 0. Let's say, okay, that's equal to 0. Now, we want to solve. This is helpful to solve for x when it's equal to 0 because now all I can do is I can look at this term here and say, okay, if this term was 0, let's, right, like if this whole thing in brackets here ended up being 0, that would make this entire thing equal to 0, right? Because 0 times anything is 0. So really all I'm asking is what would x need to be here to make this equal to 0? Well, it would have to be -3, right? That's what x would need to be. If x was -3, then that'd be -3 plus 3. That'd be 0. That would make this whole thing 0. So then this would be equal to 0. So my answer is, once you get to this point, I can say x is equal to -3. But then I can also look at this one and say, okay, what would x need to be here to make it equal to 0? And it would be equal to 2. So you've got two answers. When I say solve this equation when it equals 0, it would be equal to -3, but it would also be equal to +2. And that's helpful because that's what this was, right? Our x-intercept was at 2 and -3. We just found where this thing crosses the x-axis. That was kind of the whole point of this, right? So we're going to get quite a lot of like times where I might say, okay, what are the x-intercepts? You're going to have to know that that means I got to set y equal to 0, factor it, and then do this method where you're saying, okay, what would that have to be to make it equal to 0? It's just that it's a totally different way of solving problems now. Okay, so let's look at this one. So y is equal to x squared minus 2x minus 8. I'm going to, just for a little bit more visual, I'm going to use that gizmo or that simulator. So it's the same thing as your graph, right? It's just I'm just putting the numbers in there. So the first number is going to be 1, -2, and the last one's going to be... All right, so here's our graph, and I can't quite see the bottom here. But you can see that our x-intercepts are going to be at -2, and they're going to be at 4. So -2 and 4. Let's see if that's right. So let's factor this thing. So our function is y is equal to x squared minus 2x minus 8. Minus 8, yeah. Okay, and what we want to do is set y equal to 0. So I'm just going to put 0 on this side. Notice it doesn't matter what side of the equation the 0 is on, right? So 0 is equal to, now we got to factor this thing. So let's factor this by going bracket, bracket. Needs to multiply to 8, needs to add to 2. So what about 4 and 2? So it needs to be negative 4 and positive 2. And I forgot the x's. So there you go. So now, though, if I'm looking at this, now I say, what's x equal to when y is equal to 0? Well, what would this need to be to make it equal to 0? So it would be negative 2. So x is equal to negative 2. For this one, x would need to be 4 to make that equal to 0. So x would also be equal to positive 4. And dun-da-da-da, that was what our x-intercepts were. Okay, let's do some tougher ones because they're going to get tougher. So you guys can graph these if you like. I'll let you kind of skip if you want. I'd like you to solve for these two, though. So solving for this, I can even do it up here. I think we've got enough room. We can just go bracket. Then we've got x and an x. Needs to multiply to 9, add to 6. That's got to be 3 and 3. So in this one, actually, I will graph this one because it's kind of an interesting one. We've only got one answer, right? This one's going to be negative 3 and negative 3. So just x is equal to negative 3. But how does that work if, how do you only get one? I've got this thing going down and back up again. There should be always 2, right? Well, this one doesn't actually do that. If you put it in your calculator, we've got an x-intercept at negative 3, only one of them. That's because this comes down, it touches right on the x-axis, and then as soon as it touches, it comes back down again. So that's what's happening there. There's only one x-intercept because it doesn't actually cross the x-axis. It just touches the x-axis and then goes back up. All right, let's do this one. So if we're solving for this, that number up front isn't 1. It's bigger than 1. So what we got to do is go 4 and 3. So our numbers need to multiply to negative 12. 4 times negative 3. And they need to add to 1. I'd say 3 and 4 are good candidates. They need to multiply a negative 12, add to positive 1. So this is going to be positive 4 and negative 3. Let's rewrite this as 4x squared minus 3x plus 4x minus 3. Now we're going to factor this first one by grouping. So we're going to factor out just an x is all we can get out of that one. And we are left with 4x minus 3. And then over here, we can't really factor out anything. So it's just like plus 1 and then 4x minus 3. So our factors here are, I'm just going to carry this on down here. Sorry about that. Are going to be 4x minus 3 times x plus 1. That was just this and this, right? And that we said was equal to 0. So this whole time I should have been writing is equal to 0. So that's equal to 0. Now, the only thing that's a little bit different, this one's pretty simple to see. Like you can do that in your head, right? Negative 1. So one of our answers is going to be when x is equal to negative 1. But what about this one? Can you figure out what that is just in your head? Might be a little bit more difficult. What I would do is just actually set this equal to 0 because I want to know what x is equal to make this thing equal to 0. So let's make it equal to 0. Let's just write down just underneath here 4x minus 3 is equal to 0. And then just solve for x. You can do that by adding 3 to both sides, so plus 3. And then we've got 4x is equal to 3. And then x is equal to 3 over 4. So our other answer is x is equal to 3 over 4. Okay. How are you guys doing? Is this you're doing okay? You couldn't tell me if you weren't, I guess. And whoop, I've got an extra version of this question on my sheet. I'll delete that off your guys' sheet though. You won't see that. You'll just kind of pick up here. All right, so here's where we're at. Solve by factoring. So here's the steps that you're going to use for pretty much all of these. The equation must first equal 0. Keep the first term positive. What I mean by that is just don't make it like equal to negative 2x squared plus 4x minus 7 or something like that is equal to 0. Keep this positive. And the way you do that is just by factoring out a negative 1 or something out of that. So that's what that means. Factor the equation, just like what we've been doing. Solve, or each factor becomes an equation equal to 0, and then solve for it. The other thing here, though, like we were looking at this one below, this doesn't look quite like what we were doing, does it? It needs to look like what we were doing up top. You can't just go ahead and like factor this as it is. We need to get that 6 over to the left side of the equation. So what we're going to do is subtract 6 from both sides first. So we're going to have x squared minus 5x minus 6 is equal to 0. That's kind of we need to be starting at that point. Now we factor. So x and x needs to multiply to negative 6, add to negative 5. So I'd say 6 and 1. If you tried 2 and 3, you'd figure out that it didn't work. So 6 and 1. One's going to be positive, one's going to be negative. I'd say this one needs to be negative, that one's going to be positive. So now that we're at that point, I can see that x is going to be equal to negative 1, because that's what would make that equal to 0. And x would also be equal to positive 6. So those are our two answers. Okay, let's go over to B. Again, this isn't looking right. Now you have two options though. You might think, let's bring the 6 over there. We could. It's going to make it more difficult. I would say bring these two things over there, just so that our leading number out front doesn't end up negative. So let's bring 5x and 4 over to the left side. So that would be 6x squared minus 5x minus 4 is equal to 0. Now, the two numbers that we're interested in, they need to multiply to negative 24, and they need to add to negative 5. I would say 8 and 3 seem like a good candidate. So negative 24, so one's going to be negative, one's going to be positive. This one's got to be negative because it's got to be negative 5 in the end. That one's going to be positive. So let's rewrite this. 6x squared minus 8x plus 3x minus 4 is equal to 0. Factor out this part. We can factor a 2 and an x out of that. We end up with 3x minus 4. Okay, and then plus, we've got, that's it. We can't really factor anything out of this one. So just 1 is sitting out front, right? And then 3x minus 4. So our two factors are 3x minus 4 and 2x plus 1 is equal to 0. Now what we got to do is figure out, okay, what would this need to be to make that equal to 0? Well, let's make a mini equation here. So this is going to be 3x minus 4 and make it equal to 0. And if you solve for that, you would get x is equal to 4 over 3. Positive 4 over 3. Okay, and then looking at this one, what would x need to be there? Well, I'm going to make another mini equation. 2x plus 1 is equal to 0. So if you rearrange that, x would be equal to negative 1 over 2. Okay, so I'm going to end that video there, but I'm going to make another video before you guys do these questions. I'm actually going to go through and pick a few of them just to make sure that you're on the right track. There's a few other kind of little examples that might kind of confuse you. So I'm going to end that one there, and I'm going to do probably 3 or 4 more in a separate video.